Hello everyone. So my today's topic is peak detector. Definition is peak detector circuits are used to determine the peak, which means maximum value of an input signal. It stores the peak value of input voltages for finite time duration until it comes to reset condition. The peak detector circuit utilizes its property of following the highest value of an input signal and storing it. The following figure shows the peak detector circuit, which consists of a diode and a capacitor. The working principle of the circuit is such that the peak of the input waveform is followed and stored in terms of voltage in the capacitor. By the time on moving further, if the circuit detects a higher peak, the new peak value is stored in the capacitor until it is discharged. The capacitor employed in the circuit is charged through the diode by the applied input signal. The small voltage drop across the diode is ignored and the capacitor is charged up to the highest peak of the applied input signal. Let us consider initially the capacitor is charged to voltage Vc. The diode employed in the circuit gets forward biased when the applied input voltage Vin exceeds the capacitor voltage Vcc, thereby allowing the circuit to behave as a voltage follower. The output voltage follows applied input voltage until Vin is more than Vc. As the input voltage Vin reduces below the value of capacitive voltage Vc, it causes the diode to get reverse biased. In such condition, the capacitor retains the value until the input again exceeds the value stored in the capacitor. The figure shows the output voltage waveform for an applied input signal. As we can see in the waveform shown above, at time t1, the circuit misses the peak of the input signal as it is less than the previous peak of the input signal, thereby allowing the capacitor to hold the value of the previously occurred peak. As it is a positive peak detector, one can also construct a negative peak detector circuit that will hold the lowest or most negative signal voltage. This is basically done by the reversing the polarities of the diode in the circuit. The following figure shows the improvement in peak detector circuit, that is modified peak detector. It is used to buffer the source of the signal from that of the capacitor. As we can see, the circuit is comprised of two op amps. However, the basic circuit of the peak detector contains only one op amp. A high impedance load is offered by the op amp A1 to the source, while op amp A2 performs buffering action in between the load and capacitor. The same basic principle is applied in this circuit also. The voltage at the output side is the similar as the peak of the input signal stored in the capacitor. Its working is such that as the input voltage becomes higher than the charge stored in the capacitor, it charges itself with the new higher value of input signal. However, for a smaller value of the input, the capacitor sticks to the previous higher value. The diode D2 employed here restricts the output of op amp A1 from reaching negative saturation. This basically provides an improvement in the recovery time of op amp A1 at the condition of attaining a higher peak than the previous. The two resistors serve as the path for the bias current of input to A1. To prevent the effect of the offset voltage, the value of the two resistors R1 and R2 are kept equal. The necessary frequency compensation must be given to op amp A1 in order to have stability against oscillations. Applications of peak detectors are as follows. It is used in the analysis of spectral and mass spectrometer. Peak detector finds its application in destructive testing. It is used for instrumentation measurement, mostly in amplitude modulated wave communication. It is widely finds application in sound measuring instruments.